Hi, this video shows you how to generate different kinds of pseudo random numbers. This video is part of a series in simulation using Python. To do simulation using Python, the first thing you need to do is to learn how to generate pseudo random numbers. So let's first import the random module random. Import random. So this module has many functions that can be used to generate all kinds of random numbers. For example, to generate a random number from the unit interval, we write random dot random. Also gamma variate. Also to generate a random number from the gamma distribution, we write random dot gamma variate. And we write the scale and shape parameters alpha and beta, for example 2 and 3, like this. Similarly, to generate numbers from the uniform distribution over the interval 1 and 100, we write random uniform 1 and 100. We can draw more than one random variable from any distribution by using, for example, the for loop. For I in range 5, print random. So this gives us 5 random numbers. Similarly, for any distribution, for example, for I in range 10, print random uniform from 5 to 10. So this way we can get a random sample of size 10 from the uniform distribution over the interval 5 and 10. So these are the 10 random numbers. We can also generate random sample. We can also generate random numbers that follow the standard normal distribution by writing random Gauss 0 and 1, mu and sigma. This gives us a random number. We can repeat this as many times as we wish. And similarly, we can use random module to generate random numbers that follow an exponential distribution with parameter 0.1, for example. To generate any set of random numbers from any distribution, we use the for loop to do so. To generate a random number that follow any normal distribution, we write random normal variate, and we write the mean, for example 10, and the standard deviation, for example 0.01. Also, we can generate integer random numbers by using random rand int and write the range of these integers. So each integer lies between 0 and 10. Let's look at this example. Define a sequence rand int from 0 to I for I in range 20. Let's look at this sequence. So we have a sequence of integers in the range of 20, like this. So this sequence, we can see this sequence by using a print sequence. So this is a sequence of integers between 0 and 19. We can shuffle this sequence by writing random shuffle sequence. Now this sequence is shuffled, so we compare the shuffled sequence with the original sequence we have here. Now let's draw a random sample from any population. For example, let S equal the list A, B, C, D, E, and F. Now this is our population, and we would like to draw a sample of size 3 from this population. So we write random sample S, the population, and the sample size, for example 4. There is a module that can help us manipulate lists of letters. We import this module to get all the ASCII lowercase letters. We write this command. So these are the whole alphabets from A to Z. We can make a sequence of these numbers by writing the command list string ASCII lowercase letters like this. So this gives us a list of all alphabets. Also, we can do the same thing with uppercase letters. So we write list string ASCII uppercase letters, and we get all the alphabets from A to Z. Now let's withdraw a random sample from these letters. So we write L equals list string ASCII uppercase this. Now we draw a sample of these letters A and 10. We draw a random sample of size 10 from these alphabets from A. So we draw a random sample of size 10 from A. We print SAM here. So these are the letters J, E, P, E, and so forth. Now we can use these random numbers to visualize some statistical distributions. And we do that by using these pseudo random numbers to visualize some statistical distributions. To do so, we use the distplot function. So we import the seaborn library as SNS. Now we would like to use the distplot function of this library to draw some data and to make a kernel density estimation of the data. The distplot function plots the histogram of the data along with the estimated PDF over the data. Let's draw some random numbers. So let n equals 100,000 like this. Now let round 1 be a random sample from the uniform distribution for I n range of n. Now to use the distplot function for round 1 data, we write SNS distplot round 1 kernel density estimation equals true, and we use color equals blue. So it's clear from this plot that these numbers are really uniformly distributed over the unit interval from 0 to 1. We do same thing for random sample from the standard normal distribution for I n range n. Now we generate 100,000 real numbers from the standard uniform distribution. Now we generate a random sample from the standard normal distribution and call this generated set rand2 by using this command random Gauss 0 and 1. Now we use distplot to draw the kernel density estimation for this data along with the histogram. We write SNS distplot rand2 kernel density estimation equals true and color equals red. Now it's clear that the rand2 data really follows a standard normal distribution.